A standard curve is a tool to determine the unknown concentration of a dissolved chemical. More specifically, a standard curve is a graph that displays absorbance values that we've determined using a spectrophotometer measuring standard samples. These standards have known concentrations of the chemical of interest. Once complete, the standard curve helps us determine a chemical's concentration in unknown samples. In other words, a standard curve displays absorbance values from solutions of known concentrations to help determine the unknown concentration in a solution. Samples with known solute concentrations are called standards, and the graph of their absorbance values is a standard curve. For this video, we'll prepare our standard curve from known dilutions of cobalt chloride. Our standards include these 6 dilutions of the stock solution. Also provided is a blank with 0 concentration of cobalt chloride. We'll use this blank to calibrate the spectrophotometer. To recall how to make these standards, review the accompanying video on preparing serial dilutions. To ensure accuracy, standards and unknown solutions must use the same solvent. In this case, the solvent is water. We also have a sample with an unknown concentration of cobalt chloride. We'll use the completed standard curve to determine the solute concentration in this unknown. A spectrophotometer measures the absorbance of each of our standard dilutions and provides data for our standard curve. Be sure to watch the video How to Use a Spectrophotometer on this website. Before measuring our standards, we need to set the spectrophotometer on the wavelength that cobalt chloride solution absorbs the best, which for our work today will be 660 nanometers. From previous work with cobalt chloride, we know that the peak absorbance is at 660 nanometers. Here are the concentrations of cobalt chloride that we've mixed as standards. 6 or 7 standard concentrations should provide enough range to include our unknown and to accurately describe the straight line of our standard curve. Next, the absorbance values of each of the standards are measured carefully. When doing so, be sure to calibrate the spectrophotometer with the blank before measurement of each standard. As you measure each standard, be sure to accurately record in your lab notes the absorbance values for each standard. All of the concentration data and absorbance values for our standards have now been collected. We're ready to construct the standard curve. Begin with a sheet of graph paper and establish an X and Y axis. Title the graph Standard Curve for Cobalt Chloride. Then label and add values to the X-axis as concentration of cobalt chloride in units of milligrams per milliliter. For this work, a scale of concentration from 0 to 50 milligrams per milliliter will work fine. Label the Y-axis as absorbance. A scale of 0 to 1.2 will work fine. Now we plot the absorbance values for each of the standard concentrations. Notice that they roughly form a straight line. The relationship of concentration and absorbance is directly proportional, that is, linear, as long as the concentrations are not extremely high. So we can draw a straight line for our standard curve. This line of best fit should lie as close as possible to each data point. Now let's use the standard curve to determine the concentration of the unknown solution of cobalt chloride. Here's how. Obtain your unknown solution as well as the solvent blank from your instructor. Calibrate the spectrophotometer to 0 with the blank. And then measure the absorbance of your unknown solution at the same wavelength at which you constructed your standard curve. For unknown A, the absorbance value was 0.75. Record in your lab notes the absorbance value for this unknown solution. Refer to your standard curve and find this absorbance value on the Y-axis. Draw a horizontal line from this point to intersect the straight line that is your standard curve. Now draw a vertical line from this intersection down from the standard curve to intersect with the X-axis. This point on the horizontal x-axis is the concentration of the unknown solution. For unknown A, the concentration is 33 milligrams per milliliter. We can now enter the concentration of the unknown solution in our data table. Notice that if you have more than one unknown, you can use the same standard curve, as long as the solute and solvent of your unknowns and known standards are the same. When you finish your work, be sure to clean your lab bench area thoroughly and safely.